Hi. In this chapter, we will learn about jet streams. Okay. What are jet streams? Okay. Pilots flying military aircraft during World War II first flew into jet streams. Okay. Now, when pilots flying in the northern hemisphere fly west, they try to avoid them. However, when flying east, they try to fly along with the jet stream. As these jet streams move around the globe, they meander side to side. In the northern hemisphere, there are two areas of jet winds. One area occurs at about 30 degree and 35 degree latitude, and the other at about 40 to 45 degree north latitude. So, what is a jet stream? Jet stream is a narrow belt of wind at a velocity of 60 knots or more. Jet streams are narrow belts of very strong winds embedded in relatively light winds. Means there are some type of streams, wind streams, which are surrounded with slow moving winds, light winds. Okay, they are seen at a height, and we will learn about that later. Okay. So, early observation of drift of cirrus clouds indicated the existence of strong winds in the upper troposphere. We have observed this thing earlier also. The drift of volcanic dust from the eruption of Krakatoa in 1883 also pointed to strong winds at higher levels. When the Krakatoa volcano erupted in 1883, we have seen the volcanic dust moving at a very fast manner due to strong winds at higher levels. that was the first time when we noticed the presence of jet streams, but now we know what are the jet streams and what it is all about, and direction of its flow, everything we know right now. Okay. So, the jet stream plays an important role in steering and formation of weather such as cyclones, hurricane tracks, and abnormal weather conditions. Since 1950, high-level wind observations with the help of radio sondes, aircraft and rockets have given us a large mass of information on jet streams. Salient features of different types of jet streams are discussed in this chapter. Okay. So, radio sondes and aircrafts and rockets are used to collect information about the jet streams mainly. As per WMO, World Met Office defines a jet stream as a strong narrow current of wind concentrated along a quasi-horizontal axis in the upper troposphere, characterized by strong vertical and lateral wind shears and featuring one or more velocity maxima. Okay. Means this is a stream of wind with cores. Some cores will be there. Core. There, this speed will be very high. The velocity of wind will be very high, and there may be one or two maximum velocities inside this core. Okay. Normally, a jet stream is thousands of kilometers in length, hundreds of kilometers in width, and some kilometers in depth. Okay. As we know, jet streams ranges from 30 degree to 35 degree latitude. So, they are of very great width, very large width of hundreds of kilometers and some kilometers in depth. The height is also some kilometers, 1 or 3 kilometers in height is also there, and hundreds of kilometers in width is also there. Okay. It is such a massive belt of fast moving wind, means very fast wind. An arbitrary lower limit of 30 meters per second is assigned to the speed of the wind along the axis of a jet stream. Okay. Okay. So, in a jet stream, the path of maximum speed is known as axis, and the tubular volume immediately surrounding it is known as the core. Okay. So in a jet stream, the path of the maximum speed is known as axis, and the tubular volume immediately surrounding the axis is called the core. Okay. The wind speed along the axis is not always uniform. Wind speed can change. It can differ from lower to higher values. Okay. At certain places on the axis, the speed reduces to well below 60 knots, constituting breaks in the jet stream. Okay. Sometimes when the speed of the wind in core reduces below 60 knots, there can be breaks in the jet stream. Okay. Quite often the axis branches into two jet streams to rejoin further the downstream. In such situations, after the break, it will branch into two streams and then converges to single jet stream in the downstream after some distance. Okay. Temperatures near a jet stream. As we can expect, temperature will be somewhat higher, around 3 degrees Celsius higher per degree of latitude in the case of many jet streams. Okay. So temperatures near adjacent to the jet stream will be higher when compared to a normal atmosphere. Okay. Of course, it is carrying a lot of energy, and so there should be a chance of increased temperature, and that is around 3 degrees Celsius per degree latitude. Okay. Then come seasonal variations. There are different types of jet streams, and so they constitute or they are considered to be the causatives of different seasons also. So what are the major types of jet streams? In troposphere, there are 4 main types of jet streams. One is Arctic jet stream or AJ, polar front jet stream PFJ, subtropical jet stream STJ, tropical jet stream TJ, and then comes stratospheric jet stream in stratospheric region at around 20 kilometers from the Arctic and Antarctic regions. So it is not considered for our flying thing. For our purpose, we consider 4 jet streams: Arctic, polar front, subtropical and tropical. Okay. Arctic jet stream is found at high level westerlies of the Arctic regions at a mean height of around 7 to 8 kilometers close to the polar tropopause. Arctic jet stream can be found near to the polar tropopause, okay, and is associated with the westerlies in Arctic region. Westerlies means westerly or easterly. What it means? Westerly means wind from west and easterly means wind from east. Okay. So that is Arctic jet stream. Then comes polar front jet stream. It is found in the high level middle latitude westerlies which lie above the surface polar front. Okay. The PFG is at a mean height of around 9 kilometers close to the middle latitude. Okay. Polar front jet stream can be seen around 9 kilometers close to the middle latitude. Yes. And the core speeds are stronger in winter than in summer. Usually in polar jet streams and polar front jet stream, the core speed of the wind will be stronger in the winter time than in the summer time. Okay. Main direction is westerly from the west, although on many occasions of the jet stream may be northwesterly or southwesterly. Normal speeds are 80 to 100 knots in the winter. You have to memorize all the names of jet streams and the speed of wind in that jet stream and the season at which we can expect them. Okay. Prominence it should be at some season, so we have to memorize the season or the name of months. Then comes subtropical jet stream, which is very important for India also. Acquires its name from the fact that it is found in the high level westerlies above the subtropical or high pressure belts. Okay, that is the reason why it is called a subtropical jet stream. We don't have to remember all that. But this type of tropopause is only to the north. Towards the south of the core, the tropical tropopause lies aloft about 4 to 5 kilometers above the jet stream core. The STJ affects India in the non-monsoon months. This is what makes it important for us. Subtropical jet stream affects India in the non-monsoon months. Okay. Then comes the tropical jet stream, more commonly known as easterly jet stream, because unlike the others, this jet stream is found in the zonal easterly wind belt of the tropics. It is found at a mean height of 14 to 15 kilometers above the mean sea level. Okay, and it is prominent in the summer and becomes very weak in the winter, just on contrary to the Arctic and polar tropical jets. This jet stream is prominent in the summer and weakens in the winter. In summer or July time, the speed might be somewhere around 60 to 80 knots, but sometimes it can go up to 120 knots also, and it is less in the winter time. Okay. Then comes stratospheric jet stream. As I told you, it is seen at the 20 kilometers region in stratosphere. And now comes the jet streams over India. Why jet streams are important for our flying? Subtropical jet stream is affected in India also. Subtropical westerly jet appears over the northern parts of Indian region in October after the withdrawal of southwest monsoon, and shift progressively southwards with the progress of winter. You have to memorize this at any cost. Subtropical jet stream appears over the northern parts of India during October after the withdrawal of southwest monsoon, and it shifts progressively southwards with the progress of winter. It reaches its southernmost position in February to March. Thereafter, it shifts back northwards and moves out of the Indian subcontinent by the end of May. You have to remember all this. In winter, the mean position of the subtropical jet is roughly at latitude 27 degrees north at a height of 12 kilometers with a mean wind speed of 100 knots. That is the speed of subtropical jet stream. Okay. Yeah. The subtropical jet streams can be seen over the Indian subcontinent for about 8 months of the year, October to May. The mean core velocities in the subtropical westerly jet stream are the lowest of the order of 60 to 70 knots in October and May, and the highest 100 to 120 knots. That is the features of subtropical jet stream. You have to memorize the values. Okay. Then easterly jet stream. With the establishment of southwest monsoon over the subcontinent, the westerly subtropical jet shift northwards, weakens and disappears. The easterly jet stream appears over the South China Seas and can be seen up to African continent, passing through the South Malaya and the Indian Peninsula. You don't have to memorize all the points. You just remember the name and which position it comes, which area it occurs. That's it. Temperature distribution. Temperature increases from north to south below the core, while the reverse in the case of the above the core. Okay. Temperature will increase from north to south below the core, while it is just opposite above the core. That's it. The normal temperature gradient below the core is about 1 degree Celsius per degree latitude, though in well-marked jet streams, steeper gradients are observed. Okay. Height of the core. Okay, at which height the core of the jet stream is present. The core of subtropical jet streams is usually found just about the extratropical tropopause. Normally, a more or less isothermal layer exists at this level before the tropical tropopause is reached. The level of maximum wind is found at 5 km below the tropical tropopause. Okay. Now comes the correlation between jet streams and weather. Jet streams constitute an integral part of the general circulation of atmosphere. The changes in the location and intensity are intimately connected with the changes in the season. Simply, jet streams are associated with the seasons and weather. Okay, that's it. Lower level jets. Lower level jets are high speed winds appearing in the lower levels between 1 to 3 kilometers and have been noticed at many places, notably in the subtropics. Okay, squalls, thunderstorms, etc. are associated with the lower level jets. Beware of the subtropical jet and what is the importance in Indian climate. Okay, how it affects Indian climate, or when it reaches reaches India and all. So you have to memorize the names, okay, of the jet streams and the speed and the direction and the season at which we can see. Okay. So that is all about the jet streams. Anyway, jet streams is a very small chapter and you can expect maximum one question from that. That's enough.